The era of the multi-million-dollar main battle tank is facing its greatest crisis, as $300 commercial drones render traditional armored formations completely defenseless on the modern battlefield. From the front lines of Eastern Europe to recent tactical simulations, elite armor has become entirely vulnerable, proving that even advanced multi-layered networks like the MIM-104 Patriot or the S-400 system are functionally useless against thousands of swarming micro-threats. This extreme imbalance leaves military assets completely exposed, leading global defense analysts to argue that on paper, the only tactical salvation for mobile units is a rapid shift toward fully independent short-range protection. Can the massive military complex of Beijing truly neutralize this threat? Or are we witnessing the permanent obsolescence of mobile armor? The answer lies in the newly deployed China Type 625E, a highly advanced mobile air defense system specifically engineered to create an autonomous screen against modern aerial swarms. Developed through a strategic partnership between Norinco and CSGC, the Type 625E combines a rapid-fire 25mm Gatling gun with 8 ready-to-fire FB-10, surface-to-air missiles. First unveiled to the public at the Zhuhai Air Show in November 2022 and integrated into People's Liberation Army medium combined arms brigades by 2024, this vehicle has officially entered international service, with Defense Intelligence confirming initial deliveries to the military of Pakistan in early 2026. By utilizing localized artificial intelligence algorithms and highly sophisticated sensors, the system is designed to identify, track, and intercept low-altitude targets entirely on its own, bypassing the need for vulnerable centralized radar networks. Before we go on, you think autonomous weapons are the true future of modern battlefield survival, or do they pose too high a risk? Hit that subscribe button to join our growing global defense community, and tell me where you are watching from. To understand why this specific combat vehicle is drawing intense scrutiny from international observers, we must examine the highly integrated dual-layer interception system engineered into the chassis. At the core of its kinetic defense is a heavy 6-barreled 25mm Gatling gun, capable of maintaining a devastating rate of fire reaching thousands of rounds per minute. This rotary cannon provides a highly effective kinetic interception envelope against low-altitude threats up to 2.5 kilometers away, and at a maximum altitude of 2 kilometers. However, the true technical breakthrough, verified in official live-fire tests in June 2025, is the integration of advanced high-efficiency and destruction projectile technology. These intelligent programmable airburst rounds are designed to detonate at a mathematically calculated distance directly in front of incoming targets, generating a dense wall of high-velocity fragments that shatters incoming swarms simultaneously. For targets operating beyond this kinetic boundary, the platform deploys a secondary long-range missile layer consisting of 8 ready-to-launch canister systems. Depending on the operational theater, the vehicle can utilize standard FN-16 infrared homing missiles with a 6-kilometer engagement range, or transition to the advanced FB-10A variant, which extends the missile interception perimeter up to 10 to 17 kilometers. This comprehensive array is mounted on a highly mobile 3-axle or 4-axle 8x8 wheeled armored vehicle chassis, capable of operating at maximum speeds of 90 to 100 kilometers per hour, allowing it to maintain continuous pace with advanced mechanized infantry formations. Crucially, the system achieves total operational autonomy, by integrating an independent X-band tracking radar and an advanced electro-optical infrared tracking turret directly onto the main fighting station. This configuration allows the vehicle to function without a vulnerable centralized control node, enabling it to operate in a completely passive mode to evade hostile anti-radiation missiles. When evaluated within the global arena of short-range air defense engineering, this integrated platform introduces a highly competitive dynamic against established Western and Russian counterparts. For over a decade, the Russian Federation relied heavily on the Pantsir S-1 platform, which utilizes dual 30mm automatic cannons. While the Russian system offers high kinetic energy, its heavy tracked or wheeled logistics frame exhibits significantly less tactical agility compared to the modern 8x8 configuration optimized by Beijing. Simultaneously, the United States military has steadily pushed forward with the SHORAD program based on the Stryker vehicle platform. However, global defense analysts frequently observe that the Western solution remains exceptionally expensive and burdened by complex aerospace supply chains, which slows down wide-scale deployment. By leveraging an entirely domestic industrial supply chain through Norinco and CSGC, China has substantially lowered the production cost per unit, allowing for rapid mass production that presents a formidable challenge in the international arms export market. This industrial capability has already yielded visible geopolitical shifts through verifiable defense milestones. In June 2025, official defense telemetry confirmed a massive live fire exercise, where a fleet of these vehicles successfully neutralized 100% of a simulated low-altitude target cluster using artificial intelligence algorithms. Following these successful trials, international intelligence reports in early 2026 confirmed that the first operational export variants had officially crossed the border to enter active service with the military of Pakistan. Confronted by evolving remote aerial reconnaissance networks along its southern border, Islamabad is strategically integrating these mobile platforms to build highly responsive tactical air defense zones. This deployment marks a pivotal transition, altering the tactical calculation for low-altitude military aviation across the South Asian theater. Despite the impressive technological integration demonstrated by this platform, leading international defense experts emphasize that several critical operational limitations remain hidden beneath the official propaganda. The first primary vulnerability centers on the 25mm caliber selection for the rotary Gatling cannon. While this configuration maximizes the volume of fire, the 25mm projectile possesses inherently less kinetic energy and a shorter effective range than the 30mm rounds used by the Russian Pantsir S-1 or the 35mm ammunition utilized by the German Gepard. If the intelligent airburst programming fails to detonate with absolute mathematical precision, the probability of neutralizing heavily armored or fast-moving low-altitude targets at the outer edge of the 2.5-kilometer perimeter drops significantly. Furthermore, this extreme rate of fire introduces a severe logistical bottleneck. Firing thousands of rounds per minute means the vehicle can completely exhaust its internal ammunition storage during a few sustained engagements, making its battlefield survival entirely dependent on the immediate proximity of specialized armored resupply trucks. In a high-intensity conflict where supply lines are disrupted, this highly advanced asset risks becoming completely defenseless. Ultimately, the deployment of this weapon system underscores a profound shift in modern military doctrine. Rather than engaging in traditional, hyper-expensive arms races, Beijing is leveraging high-speed mechanical engineering, combined with decentralized artificial intelligence, to render cost-effective aerial saturation tactics obsolete. This strategy provides a vital tactical component for the wider anti-access area denial architecture across the critical Indo-Pacific region. The true lesson here is that modern defense no longer belongs to the heaviest armor, but to the system that can process and neutralize threats at the lowest cost per engagement. Do you believe that low-cost kinetic air defense systems can truly defeat the next generation of stealth autonomous swarms? Or will electronic warfare ultimately decide the future of the battlefield? Share your thoughts in the comments below.